Hello everyone. Okay, in this video we are going to discuss a new topic which lies in chapter 5 of your module, where we are going to discuss the part of antiderivative, or known as integration rules. So here we are going to see what is the relation between differentiation, the things that we discussed in chapter 4, with the integration in chapter 5. So when we deal with a differentiation, or the symbol that we are going to use it as d over dx, let's say here we try to differentiate for x to the power of 2. It's already know that we are going to get the answer supposed to be 2x. You can refer to the videos in the differentiation techniques, where if we try to differentiate x power of 2, we try to differentiate x to the power of any constant k. So basically we are going to get here kx k minus 1. This is the formula that we discussed in a previous chapter. So if we try to differentiate x to the power of 2, where the value of k now is 2, so we are going to get here 2x 2 minus 1, which is you are supposed to get 1 here. So you are going to get here the final answer is supposed to be 2x. So the process from x squared to the 2x, we call it as differentiation process or differentiation techniques. Okay, all right. So if we reverse the process from 2x to x power of 2, we call it as integration, or antiderivative. As easy as that. Okay, so basically if you know how to differentiate, you are supposed to know how to integrate. Alright, you can see the process, the following process here. Okay, so you can read it by your own, try to understand it better. And also you can read here, if we try to differentiate x power of 3, for example here, if we try to differentiate x to the power of 3, we are supposed to get here 3x squared. So if we want to find the antiderivative, so if you want to find the antiderivative of three x squared, we can see that the answer is supposed to be x cubed, because we just need to reverse the process of derivatives. Okay, or another things that we can use in order to determine the antiderivative is the basic rules here, where we can see that the value of fx is referred to a function. Okay, so if we try to integrate a function with a same limit a and a here, so basically you are supposed to get 0. So if we deal with the notation of integral, something like this, okay, this is a notation of your integration. So this is what we call as integration, and the value of dx here, will actually depends on the value of your variables. If you use the variables of y, so basically we are going to get here integrate with respect to y. If you use a variable of w, you are going to get here the integration with respect to dw. So it depends on your variable. So in this case, let's say we use the variables of x, so we are going to differentiate with respect to x. But here, since the interval that we have here is a and a, where the bottom one here, a here, we call it as a lower limit, and another a here at the upper part, we call it as the upper limit. So if we have the same value there, immediately you can say that our answer is 0. For example, if I ask you to integrate 1 to 1 of your x to the power of 2 dx, so you basically can say that our answer is supposed to be x cubed over 3. So how to get x cubed over 3, I will explain it later, but here you just need to put 1 and 1. So we are going to start with substituting the upper limit at the value of x first, which is you are supposed to get here 1 power of 3 over 3. Then you are going to minus with the value of your lower limit into x, which is you are going to get here 1 over 3. So basically you have the same value, so you are supposed to get here 0. Alright, but here, let's say we go for another part. What happens if we try to convert the limit from a to b over b and a? So if you see here, the arrangement is from a to b, the lower limit to the upper limit. But here we try to replace the value where we are going to switch the position. So in order to do that, you just need to add the additional of negative there. So you can see that if we try to integrate, let's say here 0 to 1 for x to the power of 2 dx, this is actually equals to the same value as negative 1, 0, because we try to switch these two values, so it will be 1 and 0. And for x squared dx, you just need to put a negative in front of your integral sign. What happens if we have the two function, where here fx is your first function and gx also become your function? So if you have the plus or minus sign, so you just need to split your integrals into two. You have the fx and gx, you just need to split into two. Okay, so this thing I will explain it later by using an example after this. Okay, let us continue with another basic techniques of integrals. So here I put additional notes. So here we can see that we are going to deal with a basic formula of antiderivatives or of integration. Let us start with assigning the value into your variables. Let's say here we got k equals to a constant. So the first formula that we are going to see, what happens if we try to integrate k with respect to any variable dx. So you are supposed to get the answer is kx 1 . For example, okay, we are going to see a simple example here. Let's say we try to integrate k now is 3, since 3 is constant a number with respect to x. So we are going to get, the answer is kx. So it will be 3x plus with c. This is supposed to be c, not 1. So I'll try to amend it. Okay, this is the example for the first example, or for the first formula. Second formula that you might encounter is, what happens if we try to integrate a function x or variable x to the power of k, to the power of a certain number, or to the power of a constant? K here is a constant with respect to x. So you are supposed to get here by using a formula. We are going to get x power of k, still the same thing, x power of k, just need to copy it again, but you need to plus it with 1 over k plus with 1 plus with c. Okay, immediate example that we can see here is, let's say the question asks you to integrate x to the power of 2 dx. Okay, I think I already showed you how to integrate this part. So you are going to get here x power of k, which is the value of k now, is equals to 2. So you are going to get here x 2 plus 1 over 2 plus 1 plus with c. So your answer will be x cubed over 3 plus c. So this is the way how you do the integration. You need to memorize these two formulas first. Right, and the last part here, basically, what happens if you have the coefficient in front of your x to the power of k? So basically you have the same x power of k here, x power of k dx. So what you need to do here, you just need to bring a to the front or outside the integrals, and then you just need to deal with x power of k dx, where you are supposed to get here a multiply with x k plus 1 over k plus 1 plus with c. So this is your formula, the third formula. So please try to write this formula in your own notes, and we are going to refer it time by time when we try to do any exercise later. So in next video, I will show you the specific example of how to do the integration for a basic function. Alright, so see you in the next video.